Ah! Already did.
And it's happening already.
Stop. You guys. Command Z. Alright. We're going to simplify radicals today and tomorrow, something that you've done in the past. A radical is also known as the square root symbol. You see it all over your paper right now? Yeah. Okay. So we're going to simplify these. We're going to break them down. We won't have any decimal answers. You will hardly use your calculator today unless you're not very good at your math facts. Otherwise, you shouldn't use a calculator. Square root symbol, also known as a radical symbol. The number underneath of a radical is called the radicand. So instead of saying 144 is the number underneath of the radical, I can just say 144 is the radicand. Okay. By definition, last year you would have learned that a number b is a square root of the number a if b squared is equal to a. So since 3 squared is equal to 9, then I'm going to say that 3 is a square root of 9. Okay. That's what we're thinking about today, are square roots and all your perfect squares. So at the top of your paper, if I were you, I would list what your perfect squares are. Pop, what's 1 squared?
Me?
Mm-hmm. 1. Good. Yes, Pop. Jackson, what's 2 squared? Good. Popping up. 3 squared. 9. Good. Maddie, what about 4 squared? 16. Brooke, what about 5 squared? 25. Maddie, what about 6 squared? 36. Good. So what? Brad, 7 squared. 49. Bobs, 8 squared. 64. Caitlin, 9 squared. 81. Ruth, 10 squared. 100. Bailey, 11 squared. 120. Nice. Julia, 12 squared. 144. Awesome. Hopefully you all know 1 through 12 there. Anyone have 13 squared? 169. 14 squared? 196. 196. You just flip the 6 and 9 around from the 13. 15 squared? You little calculator cheaters. Alright. You'll want to know the 1 through 15, so you probably already know 1 through 12. So get your 13, 14, and 15 put in your bank there. These are the numbers that you're looking to divide by today. And so if I give you like the square root of 424, you want to try and divide 424 by one of these perfect squares. Okay? If you're not able to divide it by a perfect square, then that means you can't break it down. So you just want to focus on dividing by those numbers. There's 3 reminders there typed up for when you simplify a square root. You can have no perfect square factors left underneath of the radical except 1. I'll explain that when we get to 1 a little more. Number 2, you can have no fractions or decimals left underneath of a radical. So if you think you're done and you box the answer, square root of 1/2, you're wrong. You can't leave a fraction underneath of a square root symbol. Okay? Nor can you leave a decimal under there. So don't ever circle an answer like that, the square root of 24. You have to turn this back to a fraction and then I'll just show you how to break it down from there. But no fractions or decimals under the radical. Nor can you have a radical in the denominator of a fraction. You don't ever want to leave your answer as 3 over the square root of 3. You can't have a square root symbol in the denominator. What you do to get rid of it is called rationalizing, and I have about 4 or 5 examples of that when we get there. Okay? Cool. Number 1, square root of 81. 9. The negative square root of 225. Negative 15. 3. We have the square root of 1649. I like to split these up. Whenever I have a fraction, I split it into 2 radicals. And then I look at them separately. Square root of 16, square root of 49. Can I simplify 4 over 7? Okay, then I'm done. Do I have to do that? Not necessarily, but they're not all going to be super easy where they're perfect squares on the top and the bottom. So if you get into the habit of breaking them into 2 square root symbols in the beginning, then it'll make it easier in the end. If you use a calculator, then you can probably figure out number 4. But without a calculator, you would have to think which of my perfect squares can evenly go into 625. 25, think about money. It's like $6.25. Can a quarter go into $6.25? How many quarters would it take to make $6.25? Well, how many are in $1? 4, and I have $6, so that makes 24 plus another one, 25. So 25 times 25 is 625, that's what it's telling us. What is the square root of 25? What is the square root of 25? And 5 times 5 is 25. So since this one comes out nice and even, that's actually telling us that the square root of 625 is 25. So if you had a calculator, you could probably punch it in, but I would challenge you not to use a calculator today. It's fun. Alright, 3, 4, 5, whatever the next row is. Square root of 28. Is that one of the numbers that I have listed above? Okay, so now we have to think which one of those numbers above can evenly go into 28. 4 can how many times? 7. So then you've got to rewrite this as the square root of 4 times the square root of 7. I want to see how you break it down. What's the square root of 4? 2. Do you know what the square root of 7 is? So then that stays square root of 7. Simplify. Next one, square root of 72. 72 is not a number I have listed at the top, so I want to find a number at the top that can evenly go into 72. 9. I heard 9 right away. How many times 9? 8. So I could rewrite the square root of 72 as the square root of 9 times the square root of 8. Right? 9 times 8 is 72. Okay. What is the square root of 9? 3. Is there a square root of 8? Is there a perfect square that goes into it? 4. How many times? 2. So I have to keep breaking 8 down then. I can't stop at 8 because the perfect square 4 can evenly go into it, so I have to keep going. That's what reminder number 1 is telling me. Square root of 4 is 2. So then this is 3 times 2 times the square root of 2. Since the 3 and the 2 at the beginning are both outside of the square root symbol, I can multiply them together. So then our final answer here would be 6 times the square root of 2. If they're both on the outside of a radical, you can multiply them. Okay, some of you were saying other factors of 72. What other perfect square goes into 72? 36 does. So instead of breaking it down as 9 and 8, we could have said 36 times, what? 2. Well, what is the square root of 36? Do we know what the square root of 2 is? No. Do we get the same answer? Yes. Which one was less work? The first one or the second one? Second one. The bigger the perfect square you pick out, the less work that is. We had 36 and 9. Both of those are perfect squares that evenly go into 72. But if you take the greater one, then you actually have less work in the end. So if you find where you have a number where more than one perfect square goes into it evenly, pick the bigger one and it leaves you with less work. See? Alright, try the next one. Square root of 48. 48 is not listed at the top. So find a number at the top that can evenly go into it. You've got to show me your work. You have to show me how you're breaking them apart. If I'm getting just a final answer, don't count on me grading it then. if you need to, you can always list what the factors of that number are. If you're more of a visual person. And then go from there. 1 and 48, neither of those are on my list. Well, I guess 1 is, but we don't even need to worry about that one. 2 and 24, neither of those are perfect squares, so I'm not going to worry about using those two. 6 and 8, are either of those perfect squares? No, they're not listed at the top of your paper, so I'm not going to try and break it down with those then. 16 is a perfect square, as is 4. If I pick the greater one, it's less work. So if I break down 48 as the square root of 16 times the square root of 3, what's the square root of 16? Do I know what the square root of 8 is? Or excuse me, of 3? No. So then I would stop at 4 square root of 3. If you didn't think of 16 and 3, it's not a common one to think of, and you thought 4 and 12, you should still get to the same answer. 48 can be rewritten as the square root of 4 times the square root of 12. Well, what's the square root of 4? 2. Is there a perfect square that can go into 12? 4. How many times? So I need to rewrite 12 as 4 times 3. And the square root of 4 is, now I've got 2 times the square root of 3. Since my 2's are both on the outside, I can multiply them together, and I get 4 square root 3. The bigger the perfect square, the less work it is. But if you don't remember them or you don't get them all, you should just check to make sure you've broken it down completely. Try the next one real quick. 3 times the square root of 54. Three stays out front when you break it apart. What perfect square can go into 54? 9. How many times? Good. What's the square root of 9? Now this is 3 times the square root of 6. 3's are both on the outside. So your final answer should be 9 square root 6 then. Questions yet? Alright, so the fraction one. Square root of 16 thirds. Like I said, I like to break these apart. Square root of 16 over the square root of 3. In the numerator, what's the square root of 16? 4. In the denominator, do we know what the square root of 3 is? No. Okay. So we're going to leave it as square root 3. Can I be done and box that answer? No. No, because you can't have a square root in the denominator. To rationalize, you multiply by the square root that's in the denominator. If you multiply the denominator of a fraction times some value, you also have to do it to the numerator of that fraction. So when you rationalize, you multiply both the numerator and denominator times that square root. Up top, 4 times the square root of 3. 4 is on the outside of a radical. 3 is on the inside, which means I can't multiply them and make them 12. It just stays 4 times the square root of 3. Because one's on the outside, one's on the inside, you don't get to multiply them together. In the denominator, I've got square root 3 times square root 3. They're both under the square root symbol, so I can multiply 3 times 3 and I get the square root of 9. Which is great, because what's the square root of 9? 3. So I've gotten rid of the square root symbol in the denominator. Up top, it stays 4 square root 3. Now we would be done here. I can't do any more simplifying to that fraction. Next one, 2 over the square root of 64. You can't have a radical in the denominator, so you could rationalize, but do I have to rationalize? No, because what's the square root of 64? 8. If you know what the square root is, then write it down there. 2 over 8, which needs to become what? 1/4. Good. Try the next one, the square root of 2/5, or 5/2, whatever it is. break them apart first. So I get square root 2 over square root 5. 2 and 5 aren't perfect squares, nor do any perfect squares go into them evenly. So I can't leave this square root 5 in the denominator. So rationalize, multiply by whatever that square root is in the denominator. And up top, square root of 2 times the square root of 5 is going to give me the square root of 10. They're both under the square root symbol, so I can multiply them together. In the denominator, the square root of 5 times the square root of 5 is going to be the square root of 25. They're both under the square root symbol. Square root of 10. Can I break that down anymore? No, there's no perfect square that goes into 10, so that stays square root of 10. Square root of 25. Can I break that down? 5. Done. Square root of 10 all over 5. You can have square root symbols in the numerator, but you just can't have them in the denominator because it creates an irrational number. Alright. Square root of 50 75ths. There are multiple ways that you could go about starting this one and doing this one. I'm going to split it up, square root of 50 over the square root of 75. You could rationalize right away, meaning you're going to multiply the numerator and denominator by whatever that square root is in the denominator. But if I'm challenging you not to use your calculator, then I wouldn't do this. Because I wouldn't want you to multiply 75 times 75 without a calculator. So instead of rationalizing, you can look to break these apart using your perfect squares. So the square root of 50, what perfect square can go into 50? 25. How many times? Twice. So I can rewrite this as the square root of 25 times the square root of 2. Denominator. What perfect square goes into 75? 25. How many times this time? 3. In a fraction, if there's no plus signs or minus signs, and I have something over itself, what's going to happen to that? It's going to cancel out. So now all we have is the square root of 2 over the square root of 3. Can I be done? No, because I can't leave that square root of 3 in the denominator. Rationalize, multiply by the square root of 3. Up top, square root of 2 times the square root of 3 is the square root of 6. Underneath, the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is just what? 3. So then our final answer is the square root of 6 all over 3. If you're someone who doesn't mind fractions and you like simplifying, then I would suggest to look to simplify your fractions at the beginning. We started with the fraction 50 over 75. Well, what number goes into 50 and 75? 25. So if I reduce by 25, wouldn't that give us 2/3 right there too? And then I could have split that up and done square root of 2 times or over the square root of 3. So if you have a fraction underneath and you like small numbers, then simplify right away. I wouldn't have even had to try and find the perfect square that was in there. It just so happened to be the same numbers. Alright? Okay, we have 5 more. 3 square root 7 squared. What does it mean to square something? Take it times itself. So we're taking 3 square root 7 times 3 square root 7. Multiplying a quantity times itself. The numbers or the parts that are on the like sides of the radical on the outside versus the inside are the ones that get multiplied together. So the 3's are both outside of the radical, so I get to multiply them together. What's 3 times 3? 9. The 7's are both under the radical, so I can multiply them together. What's the square root of 7 times the square root of 7? Square root of 49. What is the square root of 49? 7. So now this becomes 9 times 7, which will give us 63. To square something means take it times itself. You need to write it out. Okay, that next one, square root of 6 times the square root of 8. Multiply those together. What's 6 times 8? Okay, so that becomes the square root of 48. And then you can break that down using your perfect squares. Did it already up above. 48 can be broken down 16 and 3. Square root of 16 is 4. I don't know what the square root of 3 is. So that's 4 square root of 3. This next one, we're adding and subtracting radicals. You have to have the same radicand in order to do that. When you multiply radicals, like the one we just did, number 14, you can multiply the numbers as long as they're both under the square root symbol. But in order to add or subtract them, you have to have the same number underneath the square root symbol. And right now they're all different. One's a 45, one's a 20, and one's 125. So I need to try and simplify these so that I can get the same radicand. 45. What perfect square goes into 45? 9. How many times? 5. Okay, so this would be the square root of 9 times the square root of 5. Square root of 9 is 3. So the square root of 45 is the same as 3 square root of 5. Excuse me. Middle term, the square root of 20. What perfect square goes into 20? 4. How many times? 5. What's the square root of 4? 2. Good. So then we've got 2 square root of 5 in the middle. And then on the end, what perfect square can evenly go into 125? 25 can how many times? 5. Square root of 25 is, and then we got square root of 5. So after I simplify them, they all have a radicand of 5. So if they all have the same number underneath, the same radicand, you just add and subtract the coefficients. So 3 square root 5s minus 2 square root 5s is how many? 1 plus 5 square root 5s. 6 square root 5s then. It's kind of like 3x minus 2x plus 5x. They're all like terms. They all have the same radicand. So I can just combine them. Okay. Side note here. Square root 3 minus 2 square root 6 plus 4 square root 6 minus 1 square root 3. I want to simplify this. I'm going to combine like terms, the things that have the like radicands. So my square root of 3. 3 square root 3, negative 1 square root of 3 gives me how many square root of 3s? 2. So I'd say 2 square root of 3. And then I've got negative 2 square root 6, and then positive 4 square root 6. So how many square root of 6 would we have? 2. So then plus 2 square root 6. And then that's all the further you'd be able to write that one. That'd be the simplified form of that. So they have to have the like radicands in order to add or subtract them. Multiplying, it doesn't matter. You can multiply them. Good so far? Alright, the last two you're solving. Means you have an equal sign. It's a real equation there. 2 squared plus x squared equals 4 squared. You have to remember your order of operations when you solve equations. P, I don't have any parentheses, so what's my E stand for? Do I have some? Okay, so I have to do my exponents before I add or subtract. What's 2 squared? What's 4 squared? Okay, so I get 4 plus x squared equals 16. Now I'm going to move my like terms over, so now I'm going to subtract 4 to the right. And x squared equals 12. And I want to solve for x. So how do I turn x squared into x? Square root. Good. The inverse of squaring something is taking the square root. I got to do it to both sides, just like if I were to divide both sides by 2 or something. The square root of x squared is x. Square root of 12, well, we need to simplify this just like we've done for the rest of the worksheet. What perfect square goes into 12? 4. How many times? Square root of 4 is? Don't know the square root of 3. So there's your solution. Uno mas. Same thing, order of operations when you're solving an equation. I have parentheses this time, but can I do anything to the inside of it? No. Nope. Okay, so then I'm going to go to the exponents. So we're going to take x squared plus 3 square root 2 times itself equal to 81. My 3's are both on the outside, so I get to multiply them together. What is 3 times 3? 9. Then the 2's are both under the radical, so I get to multiply 2 times 2, and that would give me 4. So then that turns into 9 square root 4, but the square root of 4 is 2, so this is really 9 times 2, which is 18. So then we get x squared plus 18 equals 81. Subtract your 18 over to the right, so you can get x squared by itself. And you get x squared equals 63. To make x squared x, we have to square root both sides. Square root of x squared is x. Then I have to break down 63. A perfect square can evenly go into 63. 9, how many times? 7, and the square root of 9 is 3. We don't know what the square root of 7 is, so that would stay 3 square root 7. Questions? Okay. Try not to use a calculator. You guys are in high school, you should know your math facts by now. Right, Gavin? Yeah. Cool. That's your note piece of paper to hang on to and look at your worksheet. Yeah, hopefully, right?